Okay, bit of circle geometry. So we have that formula which is written on the top of the page, and that is something I would advise you learn. That gives us the equation of the centre of the circle. A and B represent the coordinate, so that would be this coordinate here. And then R obviously represents the radius of that circle. So the first thing it's asking us to do really is we need to figure out what the radius is going to be equal to. That's going to help us, isn't it? So we need to find the equation of the circle first of all, okay? So we want to think really about the circle as a centre, so let's substitute those values in, okay? So we'll have x is equal to 7, because that's the x, a value there, plus y minus 2, which is the b value, and it's equal to r squared, okay? Now, before we can figure out what r is worth, we need to go back and use the centre of the circle and the point, okay? So it goes back to coordinate geometry, really, and a little bit of Pythagoras, because it's very similar to that. So you'll have x1 minus x2, and you square your values, and you're adding y1 minus y2 and squaring your values, okay? So using your two sets of coordinates here, okay? So I'm going to do 7 take away 1 in my first bracket, and then I will have 2 minus 6 once I take away, and then minus 6 is there. So when you're substituting all that in your calculator, you get 100, and obviously the square root of 100 is 10. So putting that back in here, okay, your radius squared would be 10 squared. So you'll have that equal to 100, which will be at the top. And that then is your equation of your circle. Example 2. We have a circle of centre 2, 1, so they are your coordinates, and radius r. So part A is lovely. It says find the equation of the circle. So that's a really nice place for it to start. So it goes back to this, doesn't it? A and B are our coordinate and r is our radius. Okay, so we'll substitute those values in. X take away 2, and then plus y take away 1 squared, and it's equal to 25, which would be 5 squared. And that answers part A. Okay, that comes from 5 squared there. Okay, part B. Prove the point 6 take away 2, or 6 minus 2, is in the circle. So what we want to do now is really substitute those values in to this. So I'm just going to rewrite this for us. It comes back to this all the time. So I would suggest you learn this type of equation, okay? So then now instead of our x and y, we can now replace it with those coordinates there, okay? That's what it's asking us to do. And A and B are the original centre of the circle, which is 2 and 1. So you say 6 take away 1, and that's squared. 6 take away 2, and that's squared, and then plus minus 2 minus 1, and that's squared, and it's equal to 25. Obviously showing that value there, so you end up with 4 squared plus minus 3 squared, and it does equal 25, doesn't it? 16 plus 9 does give us 25. Okay, so that proves that you get the same value on both sides. Just to clarify, that's A and that's B, and that's your radius R, and that becomes X and Y when you're substituting in your values to that equation. Now part C is asking us to find the equation of the tangent of the circle. So this is linking in with coordinate geometry, isn't it? Now the first thing we need to do is think about our radius and gradient of that, okay? So it's Y difference over X difference, isn't it? So we're going to have minus 2 take away 1, and then we're going to all over, I tend to put that in brackets, 6 minus 2, so taking your x coordinates away from each other, that will give you minus 3/4, or 0.75. Now what we need to do is the gradient of the tangent, which is what they are asking us to find, is that word tangent, is the reciprocal of that. So flip it over, and then it will go to a positive. So that now is the gradient that I'm going to use in my equation, okay? So we will go back to this equation that you've used so many times in coordinate geometry, and then we substitute all our values in there, okay? Now the x and the y value come from that coordinate on there that they provided for us, 6 minus 2, okay? So we say y take away, or plus 2, isn't it? 2 minuses will go to a plus, and then it's equal to, on this side, 4/3, because that's our gradient that we decided we were going to use, x minus 6. And when you expand all of your brackets, collect everything on one side, you should end up with this. And obviously you can write it in the form equal to 0 at the very end. Touching circles. So we have two different types. We have one where they touch externally, which is the first formula there. So the diameter is equal to the radius of the first circle plus the radius of the second circle. And then we have one is inside the other, which is the second formula there, where you have R1 take away R2 is equal to D, which sums up the diameter, okay? D is obviously equal to the sum of their radii rather than diameter, but obviously putting two together. Touching circles. So we have two formulae, one with the external formulae there. So you have D, which is the sum of their radii, or the difference in their radii, depending on which rule. So the first one is where the circles touch externally. So you have R1 plus R2. And then the second one where you have one small circle inside the other, where R1 is minus R2. Let's have a look at an example. So C1 has the centre -2 and 1 and radius of 5. And then the second circle, C2, has a centre point 10, 6, and then the radius r. So obviously we're going to need to calculate that value of r. If the circles C1 and C2 are touching externally, so it tells us we can use this formula, find the value of r. Okay, so the first thing we want to do really is figure out putting those two coordinates together. Okay, so it's going back to this formula again, isn't it? The distance really across the side, which will be d. That's what we're trying to calculate, the distance. So we want to then put this into a formula. So it's this formula that we've spoken about before. It's the difference in y and then the difference in x, isn't it? Squaring the both values, a little bit like Pythagoras, and then adding them together. Now I'm going to take my value here, so I'm going to label that one x1 and y1, and this one x2 and y2, just because it eliminates some minuses for us. So I will say 10 take away -2 squared plus, and then 6 take away 1 squared, and when you do that you do get the square root of 169, which is equivalent to 13. Okay, so that is our value of d. Now if we go to the formula for touching externally, that's this one, so let's just write this here. Now d is 13, so we figured that one out just using our distance. R1 is the radius 1, so they tell us there it's 5, so that's going to go in there. And then R2 is the one we're trying to find. So that's a really nice, very basic equation. So 13 take away 5 is going to leave us with what we need, isn't it? So R is going to be equivalent to 8. Okay, circle geometry, and we've got an exam question. So you have circles C1 and C2 are represented below. So C1 is this first equation here, and then C2 is the second equation there, and obviously it says respectively. So part A, write down the radius and the coordinates of C1. So that's a really lovely question. You take the opposite of what's inside those brackets, so -1. Let's rewrite that. So -1 and -2, so that's your coordinate there. And then obviously the square root will give you the radius, so the square root of 25 is 5. So there you have the centre, -1, -2, and then the radius 5. Part B then goes on to say find the radius and the coordinates of the centre of C2. So let's write out this equation of C2. Now what's really important, and what I would always do first, is group all the letters that are similarly together. Okay, so that's the first thing, just rewriting it in a slightly different order to get all your y's together and all your x's together. And we write it like that. Now remembering when you're doing circle geometry, we are completing the square. So you want to do x minus half of that, which is 5 squared, take away that value, 5 squared. Do the same with y. So you'll have y minus 5 over 2, isn't it? Half of that coefficient there, 2.5 squared, and then take away 5 over 2 squared. And then you're also having that plus 25 on the end. Rewriting everything then, we'll have x minus 5 squared, so that gives you minus 25, that value there, plus y minus 5 over 2 squared, I leave it as fractions, take away 25 over 4, so that's the 5 squared and the 2 squared, plus 25 is obviously on the end already and is equal to 0. Now we've got things that will start cancelling each other out, so that minus 25 and plus 25, they will go. So what we are actually left with now is x minus 5 squared plus y minus 5 over 2 squared. So you've seen it kind of looks similar to this format now as well, doesn't it? And then it's got equal to 25 over 4. So instead of minus 25 over 4, we'll take it over the other side, so it becomes there. Now what you should notice now is that's your coordinates. Those are your numbers there for your x and y values, the opposite of what's inside those brackets. And then the square root of this will become our radius, isn't it? The square root of this number here will become our radius, okay? So if we then look, we'll have 5, and you can put 2.5 if you'd rather. I'm going to keep it as a fraction, okay? So I'm going to write it as 5 over 2, so that's my centre. And then the square root will become my radius. So the square root of 25 is 5, and the square root of 4 is going to give me 2, isn't it? So therefore you have the centre of your circle and also the radius. Now part C is a really nice question. So it goes on to say show that C1 and C2 touch, okay? Now the first thing we want to figure out is the distance. So goes back to your coordinate geometry. We have x1 minus x2 squared plus y1 minus y2 squared, using both your centre points here, aren't we, okay, to find the distance. So we're having 5 over 2 plus 2 and squared, and then doing the same with your y coordinates, you'll have 5 plus 1, obviously minus will go to a plus, squared, and then when you work all that out, you end up with 225 over 4, and obviously the square root of that, which is the same as 7.5, okay? Now that is our distance. Now in order to prove that they are touching, we want to think about this formula, don't we? So we've got our 2 radii or radius, haven't we? So we've got our 5, which is back right at the start of the question. we worked the square root of that out, didn't we? And then the second radius comes from the 5/2, which we found here. So we want to prove, when we add those two things together, we do get 7.5. And what you should notice, that does work, isn't it? 5 plus 2.5, the same as 5/2, is 7.5. And therefore you can say C1 and C2, they do touch, don't they? That's what we're trying to prove.